Pritchard will now explain how to modify the Reflex workflow.
It's not changing, Lodo. Okay, so we've had a nice introduction so far, all very user-friendly. We're going to get a little bit technical now. ESO Reflex is the recipe execution workbench. This is taken directly from the user manual. The important point I want to point out here is it's built on top of Kepler. And Kepler is something that exists somewhere outside of ESO. And Kepler has its own version. So don't get confused when you download ESO Reflex 2.9. You start it up and the first thing you see is, woohoo, 2.5. That's Kepler, is that 2.5? Yes. But ESO Reflex, if you look back in your terminal window, you'll see is at 2.9. Well, it will be in a couple of months' time, at the end of April, when the latest releases come through. We deliberately made the choice today of demonstrating with the development version so that you would see the new features that actually work now, like being able to turn on save these parameters. In the version that you have, the public version at the moment, save these parameters for the next iterations doesn't work. It'll work after April when you upgrade to 2.9. Okay, before we get started with modifications, we need to know what we're modifying. First of all, we talk about actors. Actors act on things. These are all the green-like folder thingies and a few of the other little pointy things that go around. They act on stuff in a Reflex workflow. The most important ones in a Reflex workflow are the recipe executors and the graphical display actors. We'll come to that a bit more later. Connections are the things that join them up. Just the lines, basically. And relations, these are quite important. These are little black diamonds here and there and allow stuff to be sent, either multiple things to go into one place or multiple things to come out of something and go to multiple places. Okay. I'd like to point out that I developed this on my Mac. So wherever I've got some paths for copying files or so on, and I say opt local, if you're on a RPM installed machine, then replace opt local with /usr. And if you installed this via the install script, then it's in some directory specification wherever you installed it, /install. And then the path name goes on. Now, what is it that the stuff that flows around ESO Reflex workflow? These are a set of files, basically. The set of files comes as a very old concept at ESO. It started with ESO Rex, and basically it's just a list of files and category. So, file name, bias, raw file, something like this. Something that tells the recipe how to treat the files that are coming in. For example, for a bias is very simple. You just have the list of raw files typically, but for a flat field, you would have the list of raw files, probably plus the bias. So you need a way to distinguish and tell the recipe which are the raw files of the flat and which is the master file coming in. The set of files concept has been extended now within ESO Reflex, and it includes extra concepts like purposes. There are checksums in there so that the Reflex can check whether it needs to recompute a product or not, and classes and all sorts of things. Well, that's actually about it, not all sorts of things. So softs are the things that flow around the workflow. At the beginning, you import, it searches through all your input files, it creates data sets and splits those off into sets of files that go to each of the recipe actors, basically. And the actors act on the soft that's coming in. They take that list of files, they do whatever they do to it, convert a bunch of raw files into a master bias, for example, and then they export or push out their port a soft and output soft. So the input soft might have 5 bias files, and coming out in the soft will be 1 master bias file. Okay, so to address the problem that was asked earlier, the question that was asked earlier, what's that sidebar all about? It's for editing and modifying workflows. If we go already to the workflow and start one up. Excuse me for my cumbersome. I'm working on someone else's laptop. It's never pleasant. Okay, so when you start it up, it takes some time. And I should have, like Lodo, prepared some jokes. How many Big Bang Theory fans in the audience? Okay, so chicken farmer is having problems with his chickens. He calls his physicist friend. He says, I've got some problems with my chicken. Oh, you have to wait for the second part. Science does not wait for chickens. Okay, so here we have this bar. This is all of the components that you can add to a workflow. Actually, not all of them, but a large fraction of them. Most of them, all of them except for the ones in this directory, as far as I know, are standard ones or ones that you've maybe added in your own workflow directories and so on. The majority of the ones that we use in ESO Reflex workflows are these ones, which are specific to ESO Reflex and have been developed by ESO, and you will find only in ESO Reflex workflows. You won't find these if you find a Kepler application somewhere else, unless they've stolen ours. There are a few others that are useful that we use here and there. Generic things like setting a variable, replicating an object or set of files, for example. There may be cases where you want to have, you've got a set of files that represents the calibrations, and you want to apply that same set of calibrations to multiple science files. So you need to replicate that set of calibrations, basically. So that's what that bar is for, and to a certain extent I will show you how to use it. Does that answer your question? Yes? No? Yeah? It for now, yeah. Okay, I need to go back to my presentation. Yeah, so I basically just said all of that. Yeah, now then just to add one of these actors to your workflow, it's really difficult. You grab it, you drag it, and you drop it. So here we go with the online demonstration, how to modify a workflow. Well, first of all, here's our workflow. Go back a step. It's the force UVIS workflow, nothing complicated. Force spectroscopy workflow. I'm going to use this for demonstration purposes today. I turn on the animate at runtime. 100 milliseconds. Okay, and run it. Okay, we see the little red thingies. Okay, I've already run this before apparently. So I'm just going to work with the fourth data set because it has a nice way to demonstrate what I'm trying to do. Select just that one, continue. So the chicken farmer got a friend who's a physicist. He calls his physicist friend and says, I've got a problem with my chickens. Come back to that again. Okay, so this is the calibration step, but we don't care about that because this is not the purpose of this demonstration, so we'll just disable this in future runs and continue. Got a problem with my chickens. So the physicist goes, oh, God, this joke's never going to end. Okay, same thing again, disable, and on we go. There we go, there's the spectrum. Okay, so, oh, my spectrum. Well, this big ugly thing here is something to do with sky subtraction. It doesn't work very well. It's this line here, whatever that is. But we've also got all this cosmic ray, well, a few cosmic rays. If you look here, you can see quite a few cosmic rays. You've got a great big ugly one there. The force pipeline does support cosmic ray correction, but only in certain modes of the sky subtraction. So I want to use, for some reason, I don't know why, but I want to use sky local, and sky local does not support cosmic ray subtraction. So I'm going to have to do this myself. So I'm going to show you today implementing cosmic ray subtraction in the workflow, and hopefully we'll end up with a nice cosmic ray cleaned raw image, as well as a spectrum clean from cosmic rays. Okay, so we'll keep this one because we need to see this each time. Continue the workflow, goes on and finishes. We get the, oh, that's, yeah, okay, fine. Okay, so when you're modifying ESO workflows, save, or in fact, export your work. Because in my experience, Reflex has a nasty habit of getting a bit confused and things go horribly wrong. So you will find yourself quite possibly having to go back to your previous save, doing exactly what you did, and this time it works. Whereas the last time it didn't. So there is save, but this will save a binary version of the workflow, and it's not transportable from one computer to another, or at least not from one system to the other. It's also not editable. Even when you export it as an XML, you won't be able to use it on somebody else's computer, probably, because it has the paths inside the file, and you'd need to correct the paths. Can be done, but it's not always trivial. With an XML, you can at least write a little sed script which will just replace all the paths for you. So if you are constantly switching with collaborators, for example, on a workflow, you could have a standard script that replaces the paths from his home directory to your home directory or hers or whatever. Okay, you get a warning that it doesn't save something. Don't worry about that. We'll save this in a particular working directory. Let's go to the home. Whoops, a daisy. Spec, and because I'm expecting I want to save this a number of times, I'll give it a version number and XML. So forspec.0.xml. Okay. Each time you save it, it takes quite a while to go and save, and eventually it'll come back and open a new window. So it's a good idea to close the previous window each time you go. Didn't quite have time to get restarted on my joke. So there's that window. There's the previous version. Let's close that one. There's the, can't see. Okay, fine, good. So first thing we want to do is make a little change. Let's be conservative. All I'm going to do is add an actor that lets us see the soft that's coming into / going out of one of these steps. So it's called the data filter. It's a very useful actor because it allows you to debug any changes you're making to make sure that you, as I said, the softs are what are flowing around. So you need to make sure that the soft coming out of one actor is what you expect it to be. So, hard work. So I've got the actor in the workflow. Let's zoom in a wee bit so we can see what's going on. Now to connect it up, I want to see the science that's coming out of this, as I call it, master fits router, which Wolfram mentioned earlier. So this is you've got all the data sets coming in here, and here it splits off each type of raw file to go to the appropriate actor. And the first one, or the bottom one here, is the science. So these are the science files that eventually come around and go into the science actor. To modify that, I just select the line, grab the little blue dot at the end, and drag it on to the other port. Most, if not all, of the actors have a soft in and a soft out port. And those are the principal ports that you're acting with. Data goes in, data comes out. In this case, all this actor does is take this off in, display it for you. It gives you an ability to check, to tick boxes, or to untick tick boxes if you don't want to use things. And then it sends out that selected set of files through the out port. So let's just run that again. Select just that one. Let's go. There's our actor in action. It's showing us this selection of frames. So we could, if we wanted to, let's do it just for fun, unselect that one. So we've now unselected the only science that we're trying to process. We continue, and the recipe should in fact fail, as it does. I forgot to turn on the display of the little red boxes. That's why you weren't seeing those. It fails because the recipe doesn't know how to handle when there's no science file. Perfectly normal, but it did exactly what we were expecting it to do. Okay. So that's a very simple adjustment. Next up, something a little bit more adventurous. I'm going to add a Python actor. There's a useful thing here. You can search for components if you have an idea about what they're called. Notice that there are several Python actors. There is this one, and there is this one. But the one that we need is the Reflex one. The other ones are the generic ones. I guess they'll work somehow, but they'll work in the generic way, not in the way that we've designed things to work here. So we've designed a particularly easy way to interface to Python scripts within our workflows. So again, select the one from Reflex, drag and drop it onto the workflow. You can see it doesn't have any ports on it. There's no little triangles in or out, okay? Because it's a dumb Python actor at the moment. It doesn't actually know what script it's going to run. It doesn't know what it should be doing. So we need to do that. We need to configure it. So you just double click on it to edit the parameters. I can show that a bit more slowly. If you right button click, you get a list of the things possible things you can do with it. We want to configure the actor, which is the default action if you just double click on it. Most of this we don't want to touch. We do want to tell it to work in lazy mode. That's useful. And we need to set the Python script. Before Lodo introduced me to the data filter yesterday, I used a very simple Python script to do exactly what Lodo showed me the data filter does, in a much nicer way, which is just to write in and out the soft files coming in and out to a particular point. This was part of the giraffe workflow, and I've just copied it here into a file called force in and out for the insof and the outsof. It'll write it into a directory, which I'll show you in a minute. And this is also a good file because I can show you very simply the structure of a Python actor, a Python script that it needs to have in order to be understood by Reflex. So I just move things up so that you can see the Python actor. Now watch it carefully, because after I press select, you're going to see it work for a few seconds, or half a second or so, and then magically the ports are going to appear on the side of the actor. It didn't work because it needs to have the absolute path. So let me go back to, no, not there, to here. The best way to do that at this stage is to go to the directory where it is. Where am I? JDP force. Grab the path. Paste it in. Click OK. Everybody watching the actor, There we go. You see, it's passed the Python script itself. It's found certain things in there that tell it what is the port that it needs and what they're called. And hey presto, we've got an in port and an out port. I'll show you the script itself in a moment. Let's just connect it up. Same thing as before. Select the line. It's coming out of the science fits router. Connect it up to the soft in and the other one to the soft out. It's useful to rename these actors with useful names. This is just actor to tell us in and out soft. So we call it in and out, commit. There we go. Okay. So let's run it again. Hang on, let's change the animate. Run. Uncaught exception. Interesting. See if it runs anyway. Okay, ran anyway. For some reason. We got to the data filter actor again, so it went past the in-out filter, and we're back here again. And if we continue this time without unselecting the science file, it should complete normally eventually. Yep, there we go. The Python actor doesn't do anything. Interactive, doesn't display anything. It's just a very simple actor. I'll show you it in a minute. I'll show you what it does and why it's useful, because it doesn't appear to do anything. There we go. The workflow has completed. Uncaught exception. Well, okay, let's dismiss. Let's hope it doesn't come back. We'll export it again in the hope that everything's okay. Got one. Save. Okay, so first of all, let's take a look at the script itself. This is the Python, the in-out. Oh, there it goes. It's just reloaded, sorry. So that's the new one. So that's the old one. Can close that. Close, don't need that one anymore. Discard. And we still got the new one. Right. Okay. So, most important point there, import Reflex. And basically that defines a whole bunch of stuff that Reflex needs. It's going to be annoying. Okay. Some other stuff, pyfits is useful, astropy, etc. Not quite sure why we're importing pyfits twice there. And then there's a few Reflex-specific functions, Reflex input-output, for the IO parser, for the parser, and we add options. This is basically where we're defining what ports are going to be on the actor. Okay. The inputs, we get the inputs from the parser, and the outputs, we get that as well, just to set it up as a variable. And then all that this Python actor does is set the outputs to be the same as the inputs. Right? Outputs outsoft equals inputs insoft. That's it. Everything else is handled automatically by the actor and Reflex and ESO Reflex and Kepler itself. It also writes to the terminal, hello, and the outputs. So you can see on the terminal what happened. Let's go back to the terminal and see if we can actually see that. No, Python, well, we can scroll up a wee bit. See it? No. Okay. Well, that's not important. We can, however, see the results of this. It's all recorded in the bookkeeping directory. So start another terminal. See Reflex date. Bookkeeping. So by default, everything is written into Reflex data as the Reflex root, And then the bookkeeping data is where all of the bookkeeping is kept, funnily enough, all of the working files as the recipe is working through. For spec, the only recipe that the only workflow we've been working on. And then here, a directory essentially for each actor that has been executed as part of this workflow. We see here in particular in out, the name that we gave to that Python actor. It's not the first time I've run it apparently, because there's a whole bunch of them. But you can always get to the latest instance that you just ran with the latest soft link. So we can go into that. And there, things that are automatically created like logdir and productsdir. And if we actually look at logdir and standard out, we maybe see, hello, remember? That was print hello. So that's where it ended up, in the standard out log file. And we can see that the input parameters, also known as the insof, look something like this. Most important point here that we can see that we have a file going in, and it's a sci LSS. That's its purpose, and its category, where's its category gone? Category sci LSS. Okay. Don't worry too much about all those details just at the moment. They'll all become crystal clear, no doubt, in the coming minutes. Okay, so back to the workflow. There's one thing that is not an easy drag and drop, which is a recipe executor. I'm running out of time fast. So I'll show this quickly without doing the whole thing. Not that one. Okay, so do I have time? Okay, yeah. Yeah. So to get a recipe executor, first of all, you need a composite. There's instructions in the developer's user manual, which you can download from the Reflex work page, on how to add exactly this. And there, the recommendation is you do this inside a composite actor. So you look for a composite actor, you install it in here, you open it and open actor. We want to open the actor. You get a new screen. You add an input port and an output port. And then the magic is that you instantiate a component. And the magic is org.iso.recipe executor. Org. Yeah. No. Okay, say again, hang on. Executor. There we go. Yeah, thank you. So this will then poll ESO Reflex, basically, asking what are all the recipes that are currently installed, and present you with a list of all the recipes that you can assign to this actor. So let's do something nice and simple. It's a force bias. Okay. Kepler has a habit of pasting things in the most convenient places. After you paste something, if you can't see it, which happens more often than you'd imagine, just click on the rescale button and it will then rescale to the entire field of view. And so if it's pasted something way down in the corner off the screen, you'll see, drag it back up and put it somewhere useful. So we put this one in here. We also need a few other components. We need a soft splitter, if I remember correctly, and a soft accumulator. Right, so these are the three main components. As I said, they are documented in the developer's manual, so don't worry too much. And again, it's just a simple matter of connecting up the dots. So we want to go from the in to the splitter for a start, but we'll just draw it the other way. We then come out to the in of the bias. We come out from the recipe executor to the combiner, accumulator, and we eventually go out to the out of the recipe. And this last one is the number of groups, which just tells everything how often, how many, in this case, it'll be how many sets of, how many softs are coming in, so that the recipe is run each time for each soft. Okay, so this is my version of a force bias recipe executor. Let's shrink down the window a little bit. Dun, dun, dun. And compare it to the real one. There we go. Now, there we go. They look pretty similar. They both got soft in, splitters, the recipe executor, the accumulator, and the soft out. So I could, let's give it a try, shall we? Let's replace the default one with my one. So we'll remove that. We'll rename that. Where's rename gone there? My bias. Let's put it up there. To connect it to the bias softs coming in and, oops, daisy, out and go. It's not showing the stuff again because it didn't work, but apparently it worked. Does anyone not believe me? I wouldn't. It allows you to have the, I could have done all of that on the workflow itself. The accumulator, but let's take a look at this one. Which is similar to the one actually Lodo showed you earlier. It's a bit more complicated. And this is not a complicated actor. It's the most complicated one in this workflow, but it's not particularly. So it's a matter of grouping it together to make it clean, keeping the work. I mean, if you've seen some of the complicated workflows, they're already covered in actors, and inside those actors are a bazillion actors as well. So imagine if it was all on the main canvas, BMS. To a certain extent, it also gives you modularity and allows you to easily copy and paste between workflows, which is what I'm about to show you. Okay. So, back to the original problem. We saw that we did a reduction. It looked okay, but there was cosmic rays in it, and we want to get rid of those cosmic rays because we want to keep using the sky local reduction method. We know that flames, I know that flames at least, has got a cosmic ray correction routine implemented, which is independent of the pipeline. It's a Python implementation. So we could maybe use that to here. So let's give that a go. That's going to be tricky. So let's go back to here. We can open another instance of ESO Reflex. Giraffe, not flame, sorry, giraffe. Hopefully you can copy and paste between instances of ESO Reflex. Yeah, okay. I know you can in Mac, I wasn't sure here. So the chicken. So the physicist, okay, I'll give it a try. I'll try and help you with your chickens that have a problem. He goes away and thinks about it for a few days. And he finally comes back and he says, I've got a solution for you, but for spherical chickens in a vacuum. And that's how you make a joke last. One joke to fill 7 spaces. Okay, so You probably can't see it, so I'll zoom in a wee bit. Down here, we have the cosmic ray cleaning actor, composite actor of the giraffe workflow. We actually want to grab it all. This one is set up, this is set up to be able to handle standards and science. That would be a nice feature to have in force eventually, so we'll grab the whole thing. We just copy it here. Go. Select it and copy it, I should say. Back to this one. And if we're lucky, paste. Lodo, have you got a joke yet? So, okay, yep. So as I said before, okay, here it's not actually gone outside the workflow, but it's not very convenient. Auto rescale, there it is. It's still selected for us conveniently, so we can just, without losing it, as I just did, there we go. Now it's going to be a bit trickier. So we need to grab this bit and this bit and not that bit, this bit. Yeah, I got it. Okay. We don't care about that. We can just delete that. Okay. So let's actually rearrange things a little bit just to be pretty. Don't get rid of this. Yeah, okay, all of that. We'll move that down there. And we'll move this up here. Okay, so let's take the output from our, let's zoom in a wee bit so you can see what's going in on. Yep. Try and grab that one. Plug it into the soft in, yes. And the science out to here. And if you will remember, if you were quick, you will have also noticed that the giraffe cosmic ray cleaning also required an input master bias. So we need a new connection from here. This is a new connection. So you just click on, I've already shown you that. You click on there. Sometimes they get stuck as you're trying to move them around. So just give it some, right? Close enough, and it's now attached to one of these relations that I mentioned earlier. Okay, the little black diamonds. So these little black diamonds around the place are not just points, they're actually relations. They allow you to, as you can see here, the bias is splitting from here. It goes now to the cosmic ray cleaning. It goes up to the response curve. It goes down to the force calib. It goes over to the science. And it's all coming out. There's only one line coming out of the bias actor, and the other four are coming from that relation. But you can create a new, let's just demonstrate that. You can easily create a new relation just by joining to a line that doesn't already have one. Actually, that still went to one that already existed. Where's a line that doesn't have one? Here's one. Let's just move around a wee bit. Oops. So this line here, the calib aux, doesn't have a relation on it. If you just drag this onto that line, it will create one for you. Okay, but that's not where we want to be. So we detach that and we put that onto that one. And the fact that this line now has a relation on it doesn't matter. If you want to get rid of it because you don't like it, basically you delete the relation, you delete the two lines that will disappear anyway, and you just redraw the connector between the two original. Let's just do that. Doink. Oh, it's gone. Oh, no. Voilà. Okay. So let's give it a go. That's good. It didn't crash already. Continue. That is just annoying. That's the data filter. And now it's empty. We've lost the science somewhere, presumably in the cosmic ray cleaning filter that we just added. That's no good. Too much to hope that we could just copy and paste it without any further action, but it was worth a try. And of course, the science actor has failed again because there was no science going into it. Okay, so, oh no, what do we do? No, it went through the in out. We did a test where we turned it off, where we deliberately deselected it in the data filter. But that's reset every time. That's not you can't say that as a persistent thing like you can with the other things. So we know it went in here because we saw that earlier. This is a soft combiner, so it's not going to remove anything. It's just going to... We don't know what's going on inside there yet. We haven't looked inside there. And this is a FITS router. So it's splitting things up. And actually, if we look at this, the way FITS routers work is unless you configure them otherwise, you can configure what ports they have. And if you, whatever name you give to the port, it's looking for that category. So here, this will be sending all of the files that have a category science along this line. And the other port is standard, so all of the files that have category standard. If we look at the first FITS router in this workflow, which has an output port science, we can see that there's actually an additional way to do this. You can configure which categories go out of the FITS router. So by adding a configuration variable with the name of the port underscore config, and then the list of the categories, you can define which types of files go out which ports. Okay, so this is telling us all the types of files that can possibly come out of the science port, right? So those are the ones that we want to be able to come out the other end as well. So we need to add all those science types throughout this bit that we've just added. So that's quite useful. We'll grab that string. We'll just cancel any changes there. Let's just copy and paste it into a terminal, just so that we don't lose it. That one. That one we can quit. Let's paste it there. Go, paste, there. Okay. Come back here. Okay. So we've got a FITS router here, and indeed, there's no config, so all it's sending out is any files that have science. So we need to add that configuration that it knows these other types that come from force will be sent down the right port. So we add a parameter. Do that again. We add here, in this, you can see it. Sorry for those who are not here. Come next time. Add the name of the port, typed correctly, because it won't work, underscore config, and the default values. So that list, quoted list of categories that you want to go out that port. Okay, and now when we see on the parameter of the router itself, it's added the config line. Okay, we commit that. Now, maybe there's something going on inside the cosmic ray cleaning actor itself. Let's have a look. Oh my goodness. A whole bunch of stuff going on here. So what this actor does in the giraffe workflow, it takes a SOF, a set of one or more science or standard files, and then it sends them down several paths. It has a median combine, which also has a pass-through. So the top actor, medium combine, does two things. It sends all the files through as they arrived, plus if you have more than one, it combines them 1 by 1, 2 by 2, 2 by 3, and so on, into medianed images, right? Cosmic ray cleaning simplified. It also has a branch which does a pi cosmic ray correction, which is one software for cleaning pi cosmics, and it has a second one for astroscrappy. Two different Python implementations of essentially the same thing. How long? Finished. I'm not. Or you'll be quick, right? Okay, so we're just going to concentrate on astroscrappy because we haven't got time for all the rest. If we look at that actor, we see that it's attached to a giraffe version of the astroscrappy script. I've taken the liberty of editing a version that will work for force. Since I'm out of time, I won't go through the details of what the edits all look like. Where's it gone? Get the right one this time. So I'll just describe quickly what I did, and again it's lost it because it hasn't got the path, so we need the path again. Where did the path go? It's not that one, this one. Path in. Okay. There wasn't a lot to do to modify it. All I had to do was tell it A, treat all those extra types of categories, B, allow for the fact that the giraffe master bias delivers a master bias with the overscan still on, and the force one doesn't. That was a little bit tricky. And the other thing is, in the giraffe version, we have the median bias passing through the unchanged file. Here, we're going to take a shortcut. We're going to replace the original file with the cosmic ray corrected version. In the giraffe pipeline, you get all these different versions. It processes all the different flavors, and you get to display them all, and you can compare which is the good one, which is the bad one, and so on. I'll finish this off later, and I will implement that for force. But for the moment, for today's display, we just do it simply like that. Okay. We also have an additional fits router here. So we need to do the same thing. We need to add a science config. Lost that list of types, so let's get it again. Be very precise. Kepler/Reflex is not very forgiving of getting things wrong. Okay, and I think that's everything. So let's just flick to the other window, not that one, that, not that. Where's the main one gone? There? No. Okay. Did I? What does that mean? Have a tab? Ah, there. Wow. Well, there you go. Never done that before. Okay, so here's the main workflow. Go. So off it goes. That was rather quick, probably because it's been done before, maybe. So it has actually done cosmic ray cleaning. We can inspect that apparently. No. Let's just continue. That was the data filter showing. Oh, here it comes. Well, there we go. So notice in the top image, all the, you remember that great big cosmic ray? All the cosmic ray, well, the 5 or 6 cosmic rays you had here, all gone, all cleaned up. So we've got a cosmic ray cleaned spectrum, still using SkyLocal. And more importantly, we've implemented a modification to a reflex workflow. Another advantage is we've got a lot less false detections of objects in the slit here. There's still really only one object, but okay, we've done better. Voilà. And considering that my time is up, I think I'd probably best stop there. So I hope I've managed to convince you that it's trivial to modify and create. No, it's not easy. And I know friendlier editing and development environments than Reflex. It's a bit unforgiving. It can get itself into, if you do something wrong, it can then get into a funny state. And then even when you fix it, it still won't work. And you have to go out, come back in, and then the same thing, you save it before you go out, you come back in, and it works this time. So this is a little bit why development with an ESO for new instruments takes some time. It's not trivial, it does take time, but it is powerful. It took me, I don't know, at least a week of time last year to implement cosmic ray cleaning for Giraffe, another week or two to fix up the plotting so that it would be able to handle all three. This I did in 4 hours, working out this presentation. Okay, I'll copy and paste, here we go, 4 hours. So once you've got things that you can copy and paste, it's powerful. If you want to adapt, if you want to set up a workflow for a new pipeline, try to find one that already looks something like what you want to do. If you've got some imaging, use one of the imaging pipelines workflows already. Adapt it like that. Writing it from scratch would be a much bigger proposition, I think. But maybe Wolfram has some other comments on that.
Just want to make one comment. I mean, what you showed here was quite an advanced, sophisticated change of a workflow. If it's just about adding a simple Python script along the path to do one thing, say, modify your image, add something, remove one pixel, it can be done in 5 minutes. I mean, that is really much easier. So what it's shown here is that it's real high level
well, that's what I showed with the in-out
editing.
Says hello.
Yeah, but I'm not saying that it didn't show it, but I think that should be emphasized. I mean, the simple thing is it's quiet, and that is what I think most of the users really want to do.
Yeah.
Okay, thank you. Does anyone have a quick question or online maybe? No, then let's go to the last